sample project that's in Revit, sample house, just to show what I'm talking about. If I go into a plan view here and switch on the shadows, for example, we get this kind of shadow diagram, which is graphically it can be good to show a plan like this to a client, because it just gives you a little bit more sense of what's going on when you can turn on a shadow diagram like this, and gives this kind of false sense of depth. But it's not accurate shadows, as you can see, because the shadows stop here, which means there's no roof on the house that we're showing. So it's purely a graphical thing. So we need to have a way of setting it up so it can accurately show us what the shadows would be like inside the house. And the way of doing that is actually to use a camera view. If you're used to setting up perspectives, you would come up here and select this little 3D view, and you can set up a camera like this. And the default setting for the camera is to set up a perspective. So if I press camera here, and I place it like this in the house, we get this perspective view. If I switch off the far clip, you should be able to see some of the house happening in there. So that's what you get if you just use the default view. But if I go back into the plan here and set up a camera, and I switch off the perspective view like this, just take it off, and I just place it in the house like that, we get this kind of sectional view. Again, I'm going to have to switch off the far clip because it's clipping out all the stuff in the background. So I switch that off. We're getting a kind of a sectional view, but it's actually a three-dimensional view. It's not a section view like you would get if you cut a section through the building. It's a three-dimensional view of the house. Over here, we have eye elevation and target elevation. And you can see at the moment they're both set at 1750, which is an average human height in most normal countries anyway. Where I come from, it's a little bit tall, but there you go. But that's actually lets us control what we're looking at. So if I go in here and change the eye elevation and the target elevation to whatever we need, at what level we need, we can get a straight down view that includes all the rest of the three-dimensional information as well. So let's just go into the elevation and see what the levels are. If I go to the east elevation here, we can see that level 2 is at 3 meters high. So that means if we want to get a plan view, your average plan view is 120 centimeters, 1200 millimeters above the level that you want to get a view in. So it cuts through the walls and the windows to that level. So that means I'm going to make the eye elevation of the camera here. We're going to make it 3000 plus 1200, so 4200. And we'll make the target elevation 0 and apply it. So then if I go back into this 3D view 2 that we made, it's turned it into a kind of a plan view here. You can see it's taking a cut through the whole thing. So if I switch on the shadows now, it's giving us a realistic idea of what the shadows are going to be like in the building. You can see most of it is in shadow now at this time, whatever time we've set it to. Now, I'm assuming now you all know how to set up your north, your project north and your true north, so you get the correct position of the sun. So we did all that before. If you don't know how to do that, just give me a shout when I finish talking. But we can come in here, go to sun settings, and we can select still. And here we have some. We have the 4 main, points of the year where you take a sun study from. If you take a sun study for the purposes of a planning application to the local authorities, you usually take it from those 4 points of the year: the highest point, the lowest point, and the 2 midpoints. So the summer solstice, the winter solstice, and the 2 equinoxes. So I can just set that to summer solstice. We can set it to 12. We can set it to 12 and apply it. And then it crashes. But anyway, it gives it the thing anyway. So now we can see that at 12 o'clock in summer, this is what the shadows are going to be like. So we can print this out and save it. So I'm going to save this. I'm going to rename it first of all. So I'm going to rename it. I'm going to call it Summer Shadows. Press OK. And now I'm going to duplicate it. Duplicate the view. And we'll rename this one, and we'll call it winter shadows. Oops. So then we can go back in here again to the sun settings, and we can change it to winter solstice. So it's got two functions. You can use it to design the house. Like here, for example, if you were designing this in a hot country, I would say you need a hell of a lot of sun shading in this area here, because the house is completely open, unless this is outside. I can't remember what it is, but let's assume that it's a living room. It would be, you would need to apply some sunshades that allow you to pretty much have it shadowed in the summertime. In the wintertime, it's not so important because you actually want to get sunlight into the house. So you would design your shadowing system, your shading system, in such a way that the angle was correct to keep the room shaded in the summertime, but when the sun is lower in the wintertime, it won't interrupt the majority of the light coming into the house, because you want light in the house in the wintertime, because that's when people get depressed. So you want to magnify the amount of light in the house if possible. So you can start to play with sun shading devices. You can play with depths of windows and so on, until you get it more or less correct as to what you want to do. Okay, so that's one thing. So you can make 4 pictures: what it looks like at summertime, what it looks like at wintertime, and then we have springtime and autumn as well. The other advantage of using this shadow diagram is, if you are going to planners and you want to show them the effect that your house is going to have on the surrounding areas, on the surrounding properties, you can show them that in the most extreme wintertime shading situation, the shadows will be such and such on the local, on the local areas, properties and so on. So you can. They often ask you for this, and in the old days we used to have to calculate it by hand. One of the first projects I had was when I was self-employed, was an apartment block, and the planners came and asked me for a shadow diagram. I had to go and calculate this point here, this point here. The whole thing took me about 2 days, and then I had to go around with a line and fill it in so it looked like a shadow diagram. Because that's the way we did it back then. We actually have to go back and do the maths. We don't have to do the maths anymore, which is nice. But it's also, the other thing is you don't get paid so much for it anymore, which is not so nice. But it's usually a necessity of a large scale planning applications that you do a solid shadow diagram. That's something like that. Okay? Simple enough, yeah? I think the main thing about it is, how do you set up the camera? So if you get that sorted out, you can quickly set up the shadow diagram. The other thing we can do is we can set up what's called an illuminance diagram. And an illuminance diagram actually gives us a rating as for what is the diffusion of light throughout the house. And this is something that's really getting into services territory, so Finn Arnes territory, if you want to get into the actual science of it. But often when you're designing a concept house, you need to know more or less what the light is going to be like. Now you can usually get a sense for it after a certain amount of time, but sometimes you need to convince other people who can't read drawings, like planners or clients, as to how much the light is going to be like in the house. In Revit we have this cloud render thing. If we go into view and we go into rendering cloud, and I need to sign in. Oh, let me see if I can remember my sign in. All of these cloud-based tools, you need to sign in, so it knows that you're sending it up to the cloud. Otherwise, they won't work. So when we go to rendering cloud, we go to the dialog here. Give it a minute to load. We have a couple of outputs. Output type still image. We have an option down here for an illuminance output. So if I select illuminance, we can make some changes in here. Now this is where you get into Finn Arna's territory. So if you talk to Finn Arna about this, he will probably have some opinions as to which of these sky models you use, for example. I always use daylight factor sky because that's what we used in Ireland. But you want to change the units if possible. Maybe we need to change it back before we change the units. Because we don't use foot candles in Europe. Foot candles. We use something called lux. And then there's various settings in here, but I'm not too concerned about the various settings because all I'm concerned about is a comparative image. So we make one image with a certain construction in the walls, certain type of windows, maybe certain type of sun shading. Then we make another option, which is a different type of sun shading, and then you compare the two. And that's the best concept stage design analysis that you can use, because at least then you have a piece of evidence you can go to your client with and say, this is evidence-based design. We've made these decisions based on this analysis by this program, which is registered and has been analyzed to show that it is actually very, very close to reality. And once you do that, let's just leave it at that. You can say start rendering, and it will send it up to the cloud and will make an Illuminance diagram. Now that's going to take a little bit of time to do. So, but when it comes back, we're going to get this multicolored image, which shows where the lighting is 100%, as in it's fully bright, all the way down to 0 at that time of the year, at that time of day. Okay, we can press continue in background. It continues going up here, and but we can continue to work on the project as it goes ahead. Okay.